The birth of stars. For stars to be born, they need the right conditions. And one of the first things they need is to have a molecular cloud. So here we're talking about essentially a dense cloud of mostly hydrogen. The molecule of the molecular is H2, so it's two hydrogen atoms bound together, and that's what forms a molecular cloud. And the picture we're seeing here is a small portion of the Eagle Nebula, which is a molecular cloud where stars are forming. Now within that molecular cloud, certain conditions are necessary to actually start the formation process. For one, you need a region of high density. You need the atoms to be close together. So we think of this as kind of like a seed that's going to grow. Because this is going to be a concentration of gravity. I don't think all that's going to fit in one line there. So you've got these tight knots. We see them in our cloud here. They're very tiny, but all of these little fingers that are sticking up, those are regions of higher density, and those are places where star formation is going to occur. Now you also need lower temperature because that way the atoms are moving slowly. And that way gravity can affect them more. Because we need gravity to pull it all together. So if the atoms are flying all over the place and going really fast, they're going to escape that gravity. So you need little slow-moving atoms that are going to get pulled back in, and they won't go very far, and they'll eventually build up and build up to start the star formation process. So as far as the steps are concerned, that molecular cloud takes care of step one. It's large, it's cool, it's a cloud, and it's hydrogen. So here we've got our large cloud of hydrogen. Nice and cool, so our atoms aren't moving around too fast. And then we're going to have gravitational collapse, and this is what the lower image shows us. So because things are cool, gravity can take over. That higher density provides that little nugget of gravity, and it's going to be essentially a kind of snowball effect. That original little region of high density is going to keep pulling more and more material in, and it's going to continue to get more and more mass, and it's all going to eventually collapse down towards the center. So when it gets to the point that it has collapsed into a ball shape, we call that a protostar. So it's not quite a star yet, but it's getting there. At least now it has a star-like shape. And so gravity is still making it collapse. At this point it's still relatively large, and gravity is the only thing acting on it. And recall from gas laws, if you take a gas and compress it, it's going to get hotter. So the temperature is going to increase. So that's going to happen here with our protostar. Because it's continuing to get smaller and smaller, it's going to continue to get hotter and hotter. So initially that heat is our one source of energy. There is no other form of energy production. So our energy is from gravitational collapse. Now typically we're going to see this in the infrared part of the spectrum rather than optical. You can see it in optical depending on the circumstances, but it's much easier to see in the infrared. When it officially becomes a main sequence star is a very specific temperature, 10 to the 7th Kelvin. So recall that's a 1 with 7 zeros after it. So that's 10 million degrees Kelvin. That's the temperature necessary for hydrogen fusion. And that's only in the core. So we're talking about the very center of our protostar is now hot enough for hydrogen fusion. This is the transition to officially become a main sequence star. So now it's going to be a star like our sun. It's going to shine from this fusion process. How long it takes to form, to actually become a main sequence from that initial gravitational collapse up to the time that it's actually a main sequence star, depends upon the mass. Higher mass, you've got more gravity. And so gravity is going to compress it down faster. So here we've got mass as our horizontal scale, time on the vertical scale, and I don't have units on the mass side here, but you can at least see the general trend that low mass stars take a very long time to form. So here we're looking at 10 million years to form, and then as your mass increases, that time scale drops pretty rapidly. So high mass stars, they're going to start forming and pop up on the main sequence very, very quickly. Low mass stars are going to take a very, very long time. But this entire process from that initial concentration of hydrogen up to the point of main sequence is the birthing process of a star.